Hello once again, dear students. Welcome to lesson 2 of college algebra under the audio program. I'm Dumisani Namakhwa, your lecturer for this course. In this lesson, we'll focus on composite and inverse functions. These are two key concepts that build on what we learned in the previous session on basic functions. So by the end of this lesson, you should be able to compose two functions, evaluate composite functions, determine the events of a function, and also you should be able to verify the correctness of an even function. So just to go back to what we did last time, we're looking at a function which is defined using f of x. So we know that a function f of x, I don't know what's happening to my, okay, yeah, it's back. So if we have a function, we define it as f of x, where f represents function and f of x represents the output. The x is our input. So this is the function that we looked at last time. So basically the definition of a function. So now let's look at the composite functions. So the composite function f of g of x means that basically we are first applying the first function, or we are first applying the function g, then we apply the function f. So let me describe what it means by composite function using a diagram. So let's say we have a function f of x equal to x plus 3. So let's say we have a function f of x equal to x plus 3. So if we have this function and we are interested in evaluating the function, at x equal to 2, the evaluation will give us the following. So if we evaluate this function at x equal to 2, we are basically doing the following. Where there's x, we are putting 2. So it means we are evaluating the function x plus 3 at x equal to 2. So f of 2 in this case is going to be equal to 2 plus 3. So where there is x, we put 2. Where there's x, we put 2. So that's evaluating a function at a point. So this is what we call evaluation. So we are evaluating. Okay, so this is evaluating a function at a point. All right, so what if we have another function, which is g of x? So let's assume we have another function, named g of x. So if we have another function, g of x, which is defined as x squared minus 5. And if we are interested in evaluating this function at a point x equal to 1, we are basically going to have the following. We are going to have g of 1, which is equal to 1 squared. So where there's x, we put 1 minus 5, which will give us negative 4. So this is basically evaluating a function at a point. So now let's go back to what we want to look at today, which is composite function. So how do we compose these functions? So let's try to compose function. So let's look at the composing. Composing two functions. Composing two functions. Okay, so I'll use the two functions that I have previously discussed with you, where we had g of x and f of x. So what if we have the following? We have an input. Let's say we have an input that is defined using x. And if we apply the function rule, so if we apply the function rule g, if we apply the function g to the input x, we are going to get an output, which is g of x. So if we apply the rule, so what I mean is, if we have, for example, the inputs 0, 1, 2, and 3. So these are just examples. So remember, g of x is a function. G is a function that is defined as x squared minus 5. So where there's x, if we put 0, we are going to have an output negative 5. So those are that's the output if we have 0. If you put 1, if you substitute 1, you get negative 4 as the output. If you substitute 2, so 2 squared, you get 4. 4 minus 5, 4 minus 5, you get negative 1. So that's the other output. If you substitute 3, you have 3 squared, which is 9 minus 5, you get 4. So these are the outputs for these particular inputs. But what if we get these inputs and apply another function rule f? So what if we apply another function rule to the inputs, to the outputs for the function g? So it means we are going to have another output. However, that output is going to be defined as f of g of x. So it's f of g of x, because you are getting the output g and you are substituting it, or you are applying f. You are applying f to the output g of x that is coming from the function g. So now the g is the input for this function f. In the previous one, x was the input for g. So x was the input for g in the first scenario. And in the second scenario, g of x is the input for the functional rule f. So it means if we take these numbers and substitute into the function f, so remember the function f, so the function f is defined as x, so it's defined as x plus 3. So this is the function x plus 3. So if we have x plus 3 as our f, so we have f defined, so we have f defined, so I'll write this as f is a function such that x is mapped to x plus 3. So I can write this the same function like this. So what will happen is that we'll get these numbers and substitute into this function. So in this case, we are going to start by substituting -5 where there's x here. Then we are going to get 2, that's -2. -4 substituted, we are going to get -1. -1 substituted, we are going to get 2. Then 4 substituted, we are going to get 7. So it means that we have come up with what is called a composite function. So a composite function in this case has been realized after combining two functions. So let me write the general case. So what we have created here in this case, it means we have f of g of x. So in this case, we say we have a composite function. And we can also write the same using the following notation. So it can be written as f open bracket, so is the circle symbol, so it's f of g of x. So these things are the same. So these things are the same. So let's look at an example of how we apply this. Okay, so let's do this example. Let me use black. Yeah. Example. let f of x be equal to 3x minus 2. Let f of x be equal to 3x minus 2. And g of x equal to x squared plus 1. Plus 1. So the first question, find f of g of 2. Number 2, find g of f of 3. So you should notice that in this case, f is outside. In the first case, f is outside. And in this other case, g is outside. All right, so you can pause it and try them out and come back to see the solutions. Okay, so I hope you have solved, and let's solve the questions together. So let's first define what we are given. So first thing, we are given that f of x is equal to 3x minus 2. And we have also been given that g of x is equal to x squared plus 1. So for us to solve the first one, we need to define what is f of g of x. So f of g of x. So to define f of g of x, this is what is going to happen. But before I show you, I think I should first explain some idea. So let me not explain it for now. So let's say we want to evaluate the function f at a point A. So let me use a different color. So let's say we are evaluating the function f at x equal to A. So what will happen is that I'll take the function f of f, which is 3x minus 2, and substitute where there is x, there's 3x minus 2, and substitute where there's x, I'll put a. So it means I'm going to have 3a minus 2. Now it means that in the case whereby we have f of g of x, I'm going to have 3 multiplied by g of x. So where there is x, So when you had a, you substituted a. Now that you have g of x, where there is x, you are now putting g of x. So you put in g of x. But not forgetting minus 2. So there is a minus 2 here. So minus 2. However, you know what g of x is. You know that one. So that one you're given. Okay. The g of x. So it means f of g of x is going to be defined as 3 multiplied by x squared plus 1. So this will be 3x squared plus 3. So that's f of g of x. Now, let's go back to the question. So the question is asking us to find f of g of 2. So in this case, it means we are going to have f of g of 2 equal to, so take note that we have x here, and here we have 2. So when we had x, here we had x. So now that we have 2, it means where there's x, we put 2. So now the answer will be 12 plus 3, which is equal to 15. So in this case, we have evaluated the function f at the g of 2. So it means the output we get from g, it has become the input for the function rule f. Alright, so let's try the other one so that we compare the answers. So the other one is g of f of 3. So g of f of 3 is going to be defined based on g of f of x. It's going to be defined based on g of f of x. So what is g of f of x? So from what I've just presented to you, you first start with defining what is your g. So g, remember, is defined as x squared plus 1. So it's x squared plus 1. So it means where there is x, we're now going to put f. So it's going to be f of x to the power 2. F of x to the power 2. So I'm here. So we put 2 where there's x, we now put f of x plus 1 plus 1. However, f of x is defined as 3x minus 2. 3x minus 2. So it means I'm going to have 3x minus 2 to the power 2 plus 1. So this is your g of f x. So remember, the question that we have is asking us to find g of f of 3, which is, in this case, 3 multiplied by 2. So where there's x, you put 2, minus 2 to the power 2 plus 1. So 3 times 2 is 6. 6 minus 2 is 4. So we get 4. 4 squared plus 1. So 4 squared is 16. Plus 1, we get 17. So that's the solution. So I'll give you some practice questions so that you can try them later on. Okay, so now let's look at the inverse functions. Inverse functions. So an inverse function, so let's have a definition. An even function, an inverse function f minus, so that's how we're going to define an inverse function of x reverses the effect of f of x reverses the effect of f of x in such a way that, if, so it reverses the effect of f of x in such a way that if f of a is equal to b, then f inverse is equal to a. So basically, we are saying that it reverses the effect of the function. So how do we find the inverse? So to find the inverse, we follow the following steps. So step number 1, replace f of x with y. So first replace f of x with y. 2. Swap x and y. 3. Solve for y. Number 4, step number 4, replace y with f inverse of function. So let's look at an example. Given f of x so given f of x equal to 2x plus 3, given f of x equal to 2x plus 3, find f inverse of x. So following the steps, so step number 1, replace. So step number 1, replace f of x with y. So replacing f of x with y, we are going to have the following. We're going to have y equal to 2x plus 3. So where there is f of x, we have put now y. Step number 2, swap x and y. Swap x and y. So swapping x and y, in our case, we are going to have x equal to 2y plus 3. So now y becomes x. So y becomes x, then x becomes y. So we have just swapped. Swap that. And you also swap that. So we have just swapped. Okay, so now that we have swapped, we have step 3. Step 3 is solve for y. So in this case, we are basically making y the subject of the formula. We are making y the subject of the formula. So in this case, if we make y the subject formula, we are going to have 2y. Okay, so we're going to have 2y equal to x minus 3. X minus 3 equal to 2y. Then this 3 will be added both sides. Then you're going to have sorry, not 3 added both sides, because we have already taken the 3 from the other side. So then we are going to divide both sides by 2, because we want to make y the subject of formula. Then y is going to be equal to x minus 3. So that's step number 3. And step number 4, is replace y with f inverse of x. Meaning that in our case, we are going to have f inverse of x, which is equal to x minus 3 divided by, so here I forgot to write divide by 2. So this is divided by 2. So that's the inverse function. So right here is the inverse function. However, there's one thing that I would like to mention. A function, for a function to exist as, or for you to have the inverse function of a function, for you to have an inverse function, we need to have the following. So for a function, or let me say, a function f inverse is the inverse of f. So f inverse is the inverse of f if, so there is a condition, if f of the inverse of x is equal to x, and f inverse of x is equal to x. So what we are trying to say here is that for an inverse function to exist, the function must be a one-to-one function. So the function must be a one-to-one function. Right. So this is the end of today's class. I have provided a PDF file. There is a PDF file that explains today's concepts. You have examples for each case, inverse functions, and also verifying an inverse function. So please check them out, how to verify an inverse. And you also have some practice questions. Try them out, and if you have any other question, please post them on Moodle or write me an email provided in the description. So in summary, today we have looked at the composite functions,